So we will have a short lecture now. So we will talk about just overview of the course, and then we'll talk about MapReduce and some other parallel computing systems. So this course is about data analysis. So we will go over some data mining algorithms in the course. So what is data mining? Some of you have taken data mining course. It is about extracting patterns and trends from large amounts of data. So it's discovering interesting and novel knowledge from usually large amounts of data. That is also a buzzword, so it is a subject of some interest, hype, and some people are afraid of it. So it is an active field because there is a lot of organizations that collect large amounts of data on a daily basis, and that data needs to be analyzed somehow, and the data has grown so much that it is difficult to analyze with a single computer, and we are moving now towards a distributed computing environment to where we have a number of machines connected together, and each one will do part of the data processing. So this course is about data mining and machine learning, because these are some methods that come from those areas that are used for data analysis. And the emphasis of the course is though on the methods or algorithms that are able to scale, in a sense that they are able to be designed in a way to work on multiple machines in parallel. So that's what we say. Emphasis on algorithms for data analysis that scale. So parallelization is essential. Parallelization, we mean that they are running in parallel or at the same time on several nodes or machines. From machine learning point of view, we can say that a model is some representation of the data. Usually we build these models because we try to predict something. So what will happen in the future? So if we want to make a prediction, then we will build a model with data. Example of that is a page rank. The page rank is a number that the Google search engine will assign to each web page, and it represents the importance of the page. So the Google will use a linked structure of the web, so usually it's in a graph form, and will compute a number for each page to tell how important the page is. Summarizes in one number all the links leading to this page, and is used to help decide which page Google will show you. Now, of course, that can change because the links on the pages change every day. We could try to build some model to predict what will happen in the future, but the fact that we have a graph of all the pages is a model of the data itself, and we can use that to calculate this page rank. So let's look at another example. If the problem is that if we think about college football, so there are teams from different colleges that will play against each other in a football game. And we have a list of teams, and we want to know which team should play with which team, in a sense that which team is better than which team. So, how are we going to determine who would win the game between the teams that have never played with each other before? So that's a form of model that we have to build because we want to predict who would win the game if we don't know if these teams played before or not and what was the result of their game. So the model will be, we can create a list from a list of these teams, and we can say the best teams are on the top. The best teams are on the top, and the worst teams is on the bottom of the list. That would be the traditional way to do it. Another way is we can assign a cost. So there's a number of teams out of order, and we'll assign a cost to each team. And we'll start with some list. We can order it by the percent that have won the game. And then we can make an incremental cost improvements until that's no longer possible. The way we do that is by swap